Hi, grade 12, still busy with exercise 9.3. And I'm going to be doing question 11 with you. Okay, so let's have a look, see what they've given us. They said here the graph shown in the diagram is y is equal to f dashed x. So what they've given here is not the original, but the derivative function, so f dashed. The values, so determine the values of x for which the function f is increasing. So before I answer any of these questions, what I would like to do is just to discuss what is happening here. So we've got a couple of x-intercepts here, which is there and there. Now, those x-intercepts for this derivative function is actually going to be the turning points for the original, okay? How do we know that? Because we're getting 0 there and 0 there. So f dashed of x equals to 0 finds the turning points. So we know that we'll have a turning point at -4 when x is -4, somewhere along here. And then we'll have another turning point at 2 also, somewhere along here. Now, this turning point for the f dashed x graph, that one over there, that is your point of inflection, okay? Then just remember what f dashed is measuring. It's measuring the gradient. So over here your y values are negative, so that means that the gradient was negative for the original. From here to here the y values are positive, so that means that the gradient of the original is positive, so it means it's increasing from there to there, the original. Then from here to here the y values are negative, so that means that the original was decreasing. And that is how we interpret this graph. So the values of x which the function f was increasing. So we're looking for where the y values here are positive. So they're positive from here all the way up to there. Okay, so question A, we are going to go from -4 up to 2. So it's increasing x as an element of -4 up to 2. Right, question B, the x coordinates of the stationary points of f. So it's -4 and 2. So question B, we get x is equal to -4, x is equal to 2 are the stationary points of the original one. Okay, so the next question C, the x coordinate of the point of inflection of f of x. So there's our point of inflection, the turning point for the f dashed. So it is -1. So our point of inflection for the original one is x is equal to -1. All right. Then question D, the values of x for which the function will be concave down. Okay. So what we're looking for now for concave down is we're looking for where the gradient of this f dashed x is negative, okay? Because you remember concave down, this bit here, concave down, happens when f double dashed of x is less than 0, okay? So that means the gradient of this one, which is f double dashed x, is less than 0, will be concave down. So you can see that the gradient of this is negative from there. Over here, the gradient is positive, so that would be concave up. So we know that we're looking for concave down, so the gradient of this is negative from 1 onwards. So this is question D. So x is an element from -1 up to infinity, both exclusive, or you can just say x is greater than -1. Okay. Then question E, draw a sketch of f of x, f dashed x, and f double dashed, showing clearly the x coordinates of the turning points of the graphs as well as the x intercepts. So they've already drawn this graph for us. This y is equal to f dashed x. And that's this graph here. Okay, so we've already got that one. What we're going to do now is I'm going to draw the f double dashed one first, So I know at my point or my turning point for this, that is going to be my point of inflection. Okay, so my point of inflection is going to be an x-intercept for my f double dashed. All right, now we know that this is from here to here. This is going to be concave up. All right, from there to there, it's concave down. Now, that means that if it's concave up, our gradient is going to be positive, so that we know that the y values for f double dash is going to be positive, so it's going to go in that direction. You see my y values are positive. Then from this point onwards, the gradient of this is negative. So that means that the y values for this onwards would be negative, and you can see they're negative like that. Okay. Now, I'm going to do the original graph. So we know that somewhere along this point here, we have a turning point. All right. Then again, along here, we know that we have a turning point. We also have a point of inflection somewhere along this line. All right. So now we know that this is concave up and then concave down. So remember, concave up is in that direction, concave down is in that direction. So from all the way from here up to our point of inflection, it's concave up. So in order for it to be concave up, our turning point must be down here somewhere. So what I'll get is I'll get something, and now guys, it's just an estimate, something like this. It's going to turn here, and then we're going to come up here, and there's going to be some kind of point of inflection over here. From this point here, it's going to be concave down. So now we're looking at a shape like this. We also know that we're going to turn here. So it's going to come up like this, it's going to turn, and then it's going to come back down. All right, and there we have a rough drawing of the other two, but it's a pretty good estimate of what the original should look like. All right, grade 12s.